Hi and welcome to today's video where we will be continuing on the running a marketplace on a LAMP stack. In this video we will be covering the order execution that supports all or none style orders. At first I'd like to mention my webpage, jimmyjohnson84.me, which covers various other technical projects. On our market, the buyers and sellers all want to be sure that either all or none of their orders get carried out. So if a buyer enters that he wants to buy 50 fishes and a seller enters that he's willing to buy 25 fishes, we can't fulfill the seller's sell order because the buyer needs to have all of his 50 fishes sold or he doesn't want to do the deal at all. We solve this problem using a binary tree. We pick a buy order from the list of all buy orders and then we build a binary tree that explores all permutations of all suitable sell orders and see if we can come up with a list of sell orders that together match the buy order on quantity. In order to make this operation more efficient, we keep all of our sell orders sorted by price in descending order. When we add a sell order to our list of sell orders, we make sure to keep the list of sell orders sorted. That way, we can use a smaller list of prices to consider when building our tree. The sell order with the highest price is at the start of the list, and this way we can find where the sell prices that are equal or smaller than our buy order prices are. The tree we will build can quickly become very large if there are a lot of sell orders, so we don't necessarily build the entire tree. We do a bit of bookkeeping while building the tree to make sure we don't build out parts of the tree that won't satisfy our needs. We keep track of the quantity accumulated at each node as well as the remaining quantity in the subnodes. We can calculate that given our list of sell orders. If the node's quantity plus remaining quantity is less than that of the buy order, we stop building out that part of the tree. We also do an early exit once we found a set of sell orders that will satisfy the buy order. As this solution requires building a tree and doing bookkeeping, I will walk through the algorithm and show a slide of the tree being built up on the side to illustrate what is going on. Alright, so we're going to start with the first example, which is finding the list of sell orders that combined make up a buy order with a quantity of 10. So in this example, all the prices are the same. We are only interested in looking at the different quantities that can together form the buy orders quantity. So let's start off here. Okay, so first we're going to create the order book here, and then we're going to print the content. So we have a buy order of the quantity of 10, and then we have the list of sell orders in here. So to make this a little bit more interesting, I've also included a sell order with a price that doesn't match, that is higher than the buy order. So this seller wants to sell it only at price 7, so it's one of those sell orders that we will not consider. And then we have 1, 2, 3, 4 sell orders that could potentially be used to match this buy order. So let's proceed then. So the first thing we start off with here is we find, so here's the reason why we want to keep the sell order sorted by price. So the first one in here is the one with the highest price, and then we have all the other ones with a lower price. So we find the starting position here that we're able to use from these sell orders. So that's 1 in this case. And then we set up our our variables here, target found, and the actual array of sell orders to execute. So out in this one we're going to get basically a list of booleans of which ones to execute and which ones to not execute given this start index. All right, so now we're going to actually figure the whole thing out. So this builds out the tree for us and considers our criterias. So if we found a node that satisfy the buy orders quantity, we managed to build out that part, and the list of the sell orders to use here, which is values to use. All right, so let's start off here. So we build the tree that we can see in here. So we build this first part here. We can see that we have the width value. There is 2 if you traverse down the width value, and you have 19 remaining. Okay, and if you were to go without the quantity 2, you would have one with 0, and you would have 19 remaining. Okay, so first we check if we reached the target value, which we did not, and then we check, okay, is it worth to continue along the path of including the sell order with quantity 2? So that we can see that it obviously is, because we haven't gone above the target value and there's enough remaining so that we could reach the target value. So then we add 1 here to the list of values to use, which means that we want to use this sell order with a quantity 2. We update current index, so now we're going to consider the sell order with quantity 3. All right, so now I'm going to step into this branch here. So now we are building out this tree here. So we are building the width node here. And yeah, let's just build it. So we can see that, yeah, sorry. We have 5 and 16 remaining here, and the one without is 2 and 16. Okay, so now we're going to see, have we reached the target value? We have not. Is it worth continuing along this path here? And it, of course, is, because we haven't gone above the target value and there's still enough remaining to reach the target value of 10. So we update the values to use here. 1, 1. We increase the current index here, and then we are going to build out the tree that's underneath here. So we're going to build a width node here. Okay, so now we're building this part of the tree. And yeah, let's build it out. So we see we have 10 and we got 11 remaining if we go on the width. And the without, we have 5 and 11 remaining. So now we're going to see we've actually reached the target value here. So I guess we're still on current index 3. Yeah, exactly. So okay, we found out that we've reached this one. We are done if we just include this value of 5 here. So we update the values to use. Got here, and then we set the target value found. And now we will just not do anything more inside of this function here. Okay, so then target value was found, and we have a set of the sell orders to use. So we want to use 2, 3, and 5. So here we also use the start index. So when we're actually going to execute the sell orders, we use the start index plus we just iterate through this list here and check, should I include this sell order? Yes, yes, and yes. And then we know that since the sell orders are sorted by price, we need to start at the start index, and then we just go through there. So I guess we can just step on out of this function, and we can see here in the output that, okay, so the buy order was executed, and these 3 sell orders were executed, the ones with the quantity 2, 3, and 5, which together form 10. And that's it. All right, so we're going to look at another example with a set of sell orders that are 5, 4, and 6 in quantity instead of the previous example. So the buy order is still for 10, but we have different sell orders coming in here. And the reason I want to show this is to sort of illustrate why we need to keep track of this, where in the index we are, and why we keep going back and forth in it in this the function that builds the tree. All right, so we create our order book first here, and so we have the same. We have a buy order for 10. Then we have the same. We have one sell order that's at a higher price than we were able to find any buy orders for. And then we have the set of sell orders that we are able to use here. So it's 5, 4, and 6. Okay, so let's see what happens when we are stepping into this. So we still find the same start index here. We're disregarding the first sell order because the price is too high. And then we start to actually build the tree using the sell orders that are available to us here. So the first thing I'm going to do is build this first tree that we can see here. So we have the first node here with 5, and then we have 10 in remaining. And if we disregard the first sell order now, and then we have nothing, and we still have 10 remaining. Okay, so what's going to happen here is that of course we haven't reached the target value, but it seems like it's a good idea to continue on this path here. So it's less than that, but there is more remaining. So we end up inserting 1 into the sell orders that we're going to use here, and then we increase the current index, and then step into the next call here. So now we are building out this part here. So let's just see that. Okay. So we get the 9, 5 plus 4, 9, and we have 6 remaining. And if we go without it, we have just a 5 then, and still 6 remaining. And yeah, of course we haven't reached the target value yet, and we're considering this one here, if it's worth continuing down this path, and it seems like it is, because we haven't gone above the target value, and there's still enough remaining to reach the target value. Alright, so we add the second cell order here with the quantity of 4, and we increase the current index, and then we step into and try to build this part here. Yeah.
right? So now we're building out this part here. And let's just have a look at that tree. So yeah, we get one node with 15, and we get another one with just a 9 then, and nothing remaining in both of these nodes there. We reached the end there. So we check, we reached the target value. No, we went above that. Okay, is it worth continuing along this path here if we could? It's not, because we've actually gone above the target value. And then we check, okay, is it worth continuing on this path here? If there was more values down here? Well, we haven't gone above the target value, but we can see that there is not enough remaining, so we don't bother doing that either. Yeah, okay, so what we end up with doing here then is we are now here, so current index is still 3. We have the 2 values to use here, but we pop one of them off. So we remove that we wanted to use number 4 here. All right, so now we're stepping back out. So current index was 3, so we decrease that, which means we're stepping back in here, and so we try to explore this one. It says that okay, so the target value is 10. We got 5. So would it be worthwhile exploring this node here? And yeah, I mean it would. 5 plus 6 is more than the target value. So we end up inserting that we don't use the value 4 here. So that's what that 0 indicates here. Yeah, we increase it to 3, the current index. So we're considering, what if we just used 5 and 6? Is that a good idea here? Yep. So I'm going to step in here. I'm going to build out this tree here. So now we built out this tree here, which we can see 11 and nothing remaining, and then 5 and nothing remaining. Okay, so we see, did we reach the target value of 10? No, we didn't. And yep, did this path here, did this reach is this worth continuing on? No, so none of these are worth continuing on, right? So that I kind of skipped that over on the if statement here, but we see that none of these paths are worth continuing exploring, since there's nothing remaining in here. All right, so there was nothing worth doing there. And what we're going to do here is then we're going to pop off the 0 here, and we're still on current index 3, but we're popping that off. So we come back out again. So now we're back stepping here. So look at the next one here. We're going to instead, yeah, so this is the part where I've actually, yeah, exactly. So now we're back out here. So current index is 3, we're decreasing it to 2. And we still have that, we're still considering to use the 5, which is on this branch. So what we're going to do is, we're going to remove that 5 as well. Which happens here.
All right, so now it's empty. And then we'll come back out again. And we're now back up here. And we're going to decrease the index that we're on. And yeah, we are going to start exploring this branch instead. So 10, and the remaining, so the current value on this path here, we end up here, is 0, but there is 10 remaining to use. So this one is worth exploring, right? So that's what we're going to do. So now we are inserting a 0 into values to use here. We're still on 1 right here, so I'm going to increase that. So now we're saying that I don't want to use the cell order, the first one here. Don't use that one. Step over to number 4 in the list of cell orders to consider here. All right, now we're stepping on into to actually build this part here. Oh, sorry. All right. Okay, cool. So now we are building out this part. So just have a look at that too. Okay, so if we don't use the one with quantity 5, but we do use number 4, then we have 4 and 6 remaining. And if we don't use the 4 either, we're still on 0 then, and we got 6 remaining. So we can see that we haven't reached the target value yet. Yep, right. And it is worth exploring this part here, the one with the width, using the cell order with quantity 4 here, because on that branch we could reach the target value. So we do that. So so far we're here at 2, and we're going to insert into the values to use here. We're inserting 1. We want to use the cell order with 4 here, and then we're stepping on to the cell order with 6. Okay. And then finally we build out this tree here. Okay, so we can see that if we use 4 and 6, we get 10, nothing remaining. If we don't use the 6, we have 4, and there is nothing remaining. So now, of course, this this condition will be met. We have reached the target value at this node here. So we simply say, okay, I want to use that one too. So now we're using 4 and 6. And we set target value found is true here. And then we are done. Yeah, and then we just do the same thing as in the first example. And yeah, the reason I wanted to show this is sort of to highlight why do we need to keep track of this index here that we're stepping back and forth in that, and this highlights that. It's when we need to backtrack that we need to use that, and when we need to pop off values on the cell orders to use. And that's it for this example. Thank you for watching.